Okay, hello everyone. We should have people now coming into the meeting here. I can't see my chat at the moment, but I have to, let me just switch over there. Okay, I can see we've got loads of people coming into the room. We'll give everyone a little bit more time, but there are already 95 people at the moment in the room. Yanina, there's loads of interest here. We are very excited to have Yanina Prystauka here from the University of Bergen, who is a postdoctoral researcher there in the cognitive neuroscience of language. And Yanina is going to speak to us today about online eye tracking and her research that she's carried out. We will just give people a few more moments to arrive before we make a start. But in the meantime, I think I can launch a quick little poll, which I've got let me just, Zoom is a bit annoying with me at the moment. There we go. So I'm going to launch a quick poll. I'm just interested in your experience with Gorilla, whether you've used Gorilla before or whether you are new to it at the moment, and then also whether you have done any eye tracking research before, and whether you've done that in the browser or in the lab, or whether you're just keen on learning more about eye tracking at the moment. Now, Yanina, I'm unsure whether you can see the poll at the moment. Can you see it at the moment coming in? Are you able to see the responses?
Yeah, it just said that panel is 10 votes.
Yeah, so that should give you a good idea as well about people's experience with Gorilla, with eye tracking. Really interesting to see that we've had loads of people who have used their eye tracking in the lab with an eye tracking device. A few of them are just, the other half of people are basically interested in learning about eye tracking because they want to use it. Or will use it. And then we've got a few curious ones and a few who have actually used WebGazer before. So that's really good to know. In terms of Gorilla experience, I can see that we've got a good split between people who have never used Gorilla before, people who have used it once or twice, and then a lot of regular users as well. So it looks like we've got a really balanced audience, which is very good to know. But for those people who have never used Gorilla before, I'm going to give you a little overview of the Gorilla tools to just give you a little bit of context of what Yanina is going to talk about a bit just after that. So I'm going to close the poll for now, and we'll make a start with Gorilla in general. So for those of you who have never used Gorilla before, Gorilla is this all-in-one platform for behavioral scientists or experimental psychologists that allows researchers to create surveys. For example, we have feature parity with something like Qualtrics. It's got a task building tool which offers feature parity and more functionality compared to, for example, ePrime. And then you can link those elements together in an experiment flow so that you can go from surveys to tasks into a randomizer, which randomizes you to different conditions, onto further tasks, which can be presented in a counterbalanced order. And then we have a few advanced tools as well. For example, a game builder that allows you to do gamified tasks, a multiplayer tool where players or participants can interact with each other, a shop builder that can be used for consumer research, and UX UI tools that allow you to test website designs, for example. Now, just to give you a little bit more of a visual representation of what that looks like, we've got a little video here on core Gorilla functionality. We support traditional reaction time tasks. We can have any type of stimulus in any response, and you get accuracy reaction time measures as well as trial-by-trial randomization. We have also a survey tool that might come in a few moments. We're still on our task builder tool here. You can see how that all works with our spreadsheet, and then you can add some randomizing options here to the spreadsheet to make sure your stimuli appear in randomized order. In terms of the survey tool, this does all the complicated things that experimental psychologists need, like the matrix survey tool, and we can support scoring and branching and subscales. Here on the screen, you can see a slider, for example, available in our survey, a multiple choice question, and you can see how participants would interact with that. In terms of scoring, this can be set up for individual items or entire pages. And then what you do is you link your tasks together, as I've said before, your questionnaires and your tasks, and you can create this experiment tree with randomization and counterbalancing. And we see some incredibly sophisticated experiments here. I think the biggest tree we've seen had over 100 nodes in it. We also have a few advanced functionalities like eye tracking, what we're going to cover today, mouse tracking, audio stimuli, microphone recordings, webcam recordings, drawing tasks, and a lot more. So hopefully that gives you a quick overview of what Gorilla can do in general. Our session today focuses on eye tracking with the webcam, and we've got Yanina Prystauka here from the University of Bergen, who's going to tell us a little bit more about her research into online eye tracking and real-time language processing. She's going to give us an overview about opportunities and efficacy for capturing psycholinguistics effects of different magnitudes and diversities. Yanina, over to you.
Sounds good. Let me share my screen. And I'll play my slides from start. Can you see it okay?
Yeah, that looks good.
Perfect. So thank you so much for having me. And Johanna, thank you so much for reading this complicated title, which sounds a bit fancy. It's based on the title of one of the papers that we published. But really, when preparing this presentation, I was trying to focus on just sharing the story of how I got to use the tool and how it played out for me. So I'll start from the very beginning with the theoretical idea that I had, and then how we made this decision to use Gorilla Online, and then some implementation tips. So the ideas come first, and my idea was about the interaction between different levels of language, between the context and the incoming lexical information. And to illustrate this idea, let me show you this example. Imagine we're in the kitchen together, and you can see a kitchen table with two mugs on it, a red and a white. And let's say some of my friends' kids forgot their toys. And you can also see a toy car, and which one is red and two are white. But let's say I'm talking to my friend, and I'm about to make coffee, and I'm providing this rather biasing linguistic context. I'm making coffee. Pass me the red mug, please. So the word coffee here is biasing. The context of the kitchen is biasing. So really, I'm expecting that when I say the red, you would be expecting the word mug to come out next, and you will be looking at the word mug. But as previous work suggests, people, even in such constraining contexts, still get sort of distracted by the lexical color word red and look at the toy car, even though it has nothing to do with the process of making coffee. So now let me show you some graphs here. This has been done using the visual world paradigm and lab-based eye tracking. This is a very standard paradigm. People are presented with 4 images in the screen, and they hear the sentence that comes in auditorily: the boy will eat the white. A very logical continuation here is the word cake. And yet, previous work shows that while people do, of course, fixate on the edible objects, the 2 cakes initially, and then the cake which is compatible with the color information, the white cake in this case, they also look a bit more at the white car relative to the brown car. It's a tiny effect, so I'm going to enlarge it. You can see this difference in looks to the white car and the brown car upon hearing white cake. So this suggests this interaction between the context and lexical information, and the fact that some people, or some participants, don't utilize context 100%, and they still attend to white objects in the scene, even though it's incompatible with the verb in this case. And moreover, previous work also suggests that this effect, this interaction between sentential context And lexical items, it varies as a function of different individual background variables, for example, language experience, vocabulary size, cognitive control, and few others. So the theoretical question I had was exactly about this. I wanted to examine this effect as a function of individual differences in a very interesting population of speakers, heritage bilinguals, specifically heritage speakers of Russian living in North America with varying degrees of proficiency. Heritage speakers are a type of bilingual speakers who grew up speaking their family language at home, but then the societal language is quite different. So the variability in language skill is very high in this population of speakers, and we would expect different individual differences related to language knowledge play out differently in this effect. However, let me remind you of the context when this has been done. It was 2021, and I was just starting my postdoc at UiT, the Arctic University of Norway. So this was the very north of Norway, which is geographically quite remote, and it was the middle of the COVID pandemic. So you can imagine that testing heritage speakers of Russian in North America was quite a challenging task in terms of logistics, of course. So we were thinking of alternative ways. And of course, we thought about moving our study online and using online eye tracking. But that came with a lot of different questions and concerns. I remember discussing the following concerns. For some reason, we were cautious about having multiple items in the display. Some of our colleagues have already been using online eye tracking with just 2 pictures, so they were splitting the screen into half, but we were concerned about having more pictures and so smaller regions of interest. Would that work online? We were also concerned about the success of calibration because there were cases when people wouldn't even get into the experiment because they couldn't calibrate well online without some additional involvement of the experimenter. Of course, we were concerned about the quality of the data. We were discussing what software to use because there were several available software at the moment. And then if using Gorilla, we were wondering whether we should proceed with some custom code that we had from some developers that we collaborated with, or shall we trust user interface and go with the built-in functionality of Gorilla. Previously, during my PhD, I used Gorilla a lot for some basic behavioral sentence processing tasks, and they worked out just well. So I was very hopeful that it will work. So after some thought, it was decided to take Gorilla to the Arctic and to go with the built-in functionality. However, we were still cautious and there were risks because it is a rather small effect. As you can see, the proportion of fixations we're talking about is about the difference in the proportion of fixations is about 5%. And we're looking at the effect of the distractors, really, not even the target. So we wanted to go or to add another effect, which would most surely replicate online. So we were thinking what effect we could use for these purposes. And let me present you with this very famous example, I guess, for anybody who took any introduction to psycholinguistics. If I give you a sentence, the boy will eat the, you'll most surely continue it with the word cake. This is a famous experiment from Altman and Komida, 1999, where you can manipulate the verb semantic constraint in relation to the visual display. And you see that if the verb is constraining and if there is only one edible object in the scene, people will start looking or attending to this object even before the object name comes up. So here you can see cumulative probability of looks to the target object, the cake in this case, as a function of the verb. It's either eat the cake, which is very biasing towards the cake, or move the cake, which is the next line down here, where all of the objects can be moved in this display. So people do look at the cake more in the eat condition relative to move condition already at the verb. So before the noun comes up. And it's a rather robust effect, which has been replicated in different languages many times. And this is the ChatGPT generated picture. I thought it looked cute, but the actual stimuli looked much simpler. So this is the original stimuli from the experiment. So we thought this effect is so robust, it's safe to have it as a just a test condition to make sure that the technology works well. And additionally, to test in heritage speakers who might have rather varying degree of proficiency, we wanted to add another sort of robust population, dominant native speakers of Russian, for whom Russian was sort of mostly the only dominant language. So having these two controls, if you want, in the pipeline, the dominant speakers and the super large effect that has been replicated many times, we felt rather safe to continue with Gorilla, and that whatever effect we would find, we would be sure that it's the effect of the manipulation rather than the software. And let me show you some trials from the experiment. Again, very traditional visual world paradigm. I'll show you two trials. One trial is from the effect test in the verb semantic constraint. So the eat or move the cake. In this case, it will be a sentence in Russian, which will go like, the woman will either water or move the plant, where water is the constraining condition and move is the non-constraining. And then another trial will be illustrating this other experiment with the eat the white cake, but in that case, it will be smoke the brown pie, I believe. So two trials illustrating the two effects we were testing, the robust, large one, and the smaller one.
Женщина польет растение. Дедушка выкурит эту черную трубку.
Okay, so in this case, it was the woman will water the plant and the grandfather will smoke this black pipe. So this was the experiment, very simple. In the rest of the presentation, I have some tips and some things to think about when implementing it, but I'm sure you probably want to see whether it worked or not before I continue so that you know whether to trust these tips and tricks. So first, I'm going to show you the large effect, the one that we were most confident about in the dominant monolingual speakers of Russian. So we collected quite a bit of data, 200 participants, and here you see proportion of looks to the cake upon hearing the boy will eat the cake. And two lines illustrate the eat condition, the constraining condition, and the blue condition. So you can see that in the eat condition, people start looking at the target already during verb duration. So this replicates beautifully experiments done in the lab. Now, I hope you're wondering about the effect observed in heritage speakers. So this is our experimental population that we were really curious about. And here, with just 68 participants and not a couple hundred, you can see that the effect replicates as well. So these are two different papers, and we didn't attempt to control the data from the two different groups quantitatively. This wasn't our question at all. But even by sort of eyeballing it on this slide, you can see that the effect is present in both populations. We can speculate about slight differences that could be due to language experience, but that's another experimental question related to individual differences in language experience. But for us, it was important to just establish that we get the main effect of looks to the target in the constraining condition, and it's there. Now I hope you're also wondering about the small effect and whether we were able to replicate it. Again, I'll start with the dominant speakers. And here we see looks to all four objects in the display. As people were hearing, the boy will eat the white. And here at 0, you see the onset of the noun cake. Of course, people start looking at edible objects upon hearing eat, and then they look at the white cake, which is the target. But we were interested in the difference between the green and the red lines, looks to the white car and the brown car. And you see that the difference is there. It looks tiny, but it's sort of maintained in time, and it's stable across our 200 participants, so it does come out significant when we model it. And most interestingly, this difference was also observed for the heritage speakers. This tiny difference was replicated there. And if anything, this effect looks even a bit larger. Again, it's just a speculation, but it could be because these people have more variable experience with language, and they can be more prone to distraction bilexical items in the biasing context. So we were quite happy. And again, this is just to show that we were able to replicate this effect. Then in each of these were two different papers, we had some additional questions about individual differences and the statistical power, but I won't focus on them here. I want to sort of move on to talking about Gorilla and implementation. So a few things I want to mention are participant recruitment and different strategies that you can use, about different kinds of instructions, video auditory, about this feature of using the full screen, about our solution to encourage participants to listen to the end of the spoken sentence, calibration, sampling rate, audio onset, and screen definition. So I'll mention a little bit details about each of these points. So participant recruitment, I think is interesting to mention because here we actually use two approaches to recruiting participants. For the monolingual dominant speakers, we really relied on the wild net and recruited people via recruitment platforms. So there was no personal contact with participants whatsoever, and the dropout rate was a bit high, 20%. Half of this was due to people not being able to go through calibration, and another half was due to low sampling rate. So we removed people when we already were analyzing and pre-processing the data. For heritage speaker, we followed a slightly different procedure. So in general, this is a hard to get population, and I would have a lot of trouble collecting this data during COVID if I had to travel from Norway to the US. But thanks to online recruitment and thanks to Ronaldo, who was our research assistant based in the US and helping with the recruitment, this was possible. So most of the invites were sent out via emails or through a personal invitation by Ronaldo, who is familiar with this population. So there was a bit more personal contact with these people, and the dropout rates were minimal. So if people didn't know how to go through calibration, they would ask Ronaldo, and he would either answer himself or redirect those people to me. So we lost maybe just very few people. And then a third recruitment type would be to have these participants with you in a Zoom session instead of supervise them doing this experiment. But we didn't have this approach. Okay, and this paper from Behavioral Research Methods is published. The other one is in press. The materials are online, so feel free to check out the analysis codes and use the stimuli or whatnot. Just to say, they were not designed as a step-by-step analysis guide, but we're currently working on that, and I will mention it a bit later. But next, I want to talk about the possibility to have fully auditory and video instructions. The population we worked in, these heritage speakers, they have large variability in experience with written language, so it could be difficult for them sometimes. So all of the instructions here were auditory or visual. For example, for calibration, I recorded myself doing the calibration and guided them through the process with this video. And the same was for obtaining consent form. So it's possible in Gorilla to do this seamlessly. Then just a quick note, to use the full screen, it's a really simple and nice feature to improve data quality, to make sure that you only see the experimental stimuli in your screen. And this is, again, this was done in 2021. Maybe now there is a special button for this, but back then you had to use script. And yeah, you had to also use script to introduce this button. So I instructed participants auditorily, please press the button to go into the full screen mode. And they did, and this functionality was supported by the code in the script tab of the Gorilla. How would you even call it? Of the Gorilla settings, let's say. Then I really wanted to make sure that participants listen to the end of the sentences, because the little effect I showed you, the white brown cake effect, was visible or most pronounced on the noun. So that is important for me that people listen to the end of the sentence without proceeding to the next trial earlier. So I went with this double screen solution where in screen 2, I had my eye tracking and the 4 images and the auditory sentence. and then the screen would advance to screen number 3 after media was finished. And by media, I mean the sentence audio, okay? And then when people advanced to the next screen, for them, it was a seamless transition they didn't see. But for me, it was important that their response was only recorded when they performed it during screen 3. So this way I could be sure that they listened to the end of the sentence. Again, maybe now there is a more advanced solution, but this one worked at a time. And here is just a very basic tip. To collect eye tracking data, you have to remember to use this option in the eye tracking zone settings. This is, I think, the basics, because this gives you the uploads folder with the data. Again, maybe there were changes in the meantime, but back then this was how you would get your eye tracking data, and sort of your coordinates one sample for each sample of your data recording. Okay. Then calibration procedure. In our case, we used calibration before the start of the experiment and then every 16 trials. And because we had 48 trials, it means that we had 3 calibration sessions, and that worked fine. Just a note that we didn't do any methodological exploration of this, although I know, and if you need, you can ask me for that or just Google. There are papers which tested this more systematically. I think there has been work where they made participants calibrate before every trial, which is quite a bit. So I think that was a bit maybe exhausting for participants. And then I know some papers which used some simulations, I believe, to test the data quality given different amount of calibrations. So you can check that out. For us, calibrating every 16 trials seemed to have worked just fine, but that would be an interesting methodological, let's say, addition to test it more purposefully. Then for the sampling rate, again, this was computed when I was already pre-processing and analyzing the data. On the left, here you can see sampling rate for the monolingual dominant speakers, and on the right for heritage speakers. Please note these are absolute numbers in terms of how many participants had the sampling rate in this particular range. I should have really translated it to percentages, but we can do it now together. And you can see that actually the monolingual dominant speakers seem to have a slightly lower sampling rate on average. And that's just something to keep in mind, that depending on the regions in the world where you're testing, there could be differences maybe in internet speed or the kinds of hardware people are using. And sometimes you end up with slightly lower sampling rate. And then I had to remove a few subjects, those with sampling rate below 10 Hertz. Just something to keep in mind, let's say, when you want to compare people from different geographical locations who might differ in this respect. Okay. Then audio onset, I think this is a critical thing to mention. So in my design, I had a preview time of 1 second, and then I wanted to play the auditory sentence 1 second later. So this was possible using, again, the scripting option in the script panel of the Gorilla settings. And then it was also critical to set this advanced setting to 1 and to get additional metrics on audio events. So if you use this option, then in the master spreadsheet, you get this kind of data where you get information on when the audio was requested to play and when it actually played. And here I'm showing you one of the extreme trial where the difference was quite substantial. It was more than 200 milliseconds. And then, of course, you want to correct your analysis, keeping this numbers in mind. And this is what I did for both of the studies. And this is just some descriptions of how this actual onset times played out in my 2 different populations. And you can see that, for example, again, for the monolingual dominant speakers, who I believe had maybe slightly worse internet speed or hardware, their onset times varied quite vastly. And there were quite a few trials where the onset times was 12 or 1,600 milliseconds, even though I asked it to be 1,000. And then here, well, we have fewer numbers but also maybe a slightly better stable connection speed and hardware. And here there was also variability, although it wasn't as huge. Okay, and then this has to do more with when you analyze your data rather than when you implement your experiment. I just wanted to draw your attention to the fact that Gorilla has this specialized normalized space, which is called the Gorilla screen, where again, so there are two screens. One is the participant-specific screen with the dimension of their screens. But because we want to compare among different participants, it is very helpful to have this normalized screen with the normalized coordinates, which go from 0 to 1 in both directions, the vertical and the horizontal. And this way you can be sure, as the Gorilla support page suggests, that if you're looking at 0.05 on both X and Y axis, for different participants, you can be sure that in both cases, this would be the center of the screen. And in my case, my regions of interest were quadrants rather than the coordinates of individual pictures. And this was critical to use this screen for defining my quadrants. Okay, so this was it in terms of implementation. These were some tips that I could think about. And now we're doing some more testing. This time we're focusing on the word level rather than sentence level. And we want to test the isolated words visual world paradigm with different populations of speakers. And this work has already been accepted for publication in this special issue of Research Methods and in Applied Linguistics. And this work will result in a step-by-step guide to analyzing webcam eye tracking data. Here it says for L2 research, but of course it will be usable and applicable for different kinds of populations and research questions, not just L2. And this work is done in collaboration with Jason Geller, Sarah Colby, and Julia Druin. And here we'll be looking at a very similar design, visual world paradigm, but now a single word version where we just, for example, play the auditory word dollar, and we manipulate the items such that you either see the dollar or phonological competitor dolphin, which shares the start of the word with the target word, a rhyme competitor collar, and an unrelated distractor. And we hope to get the same curves that were originally reported in this work by Paul Alapen and colleagues in 1998, where people do attend to the dollar, of course, but they also attend to phonological competitor a bit, and to the rhyme competitor relative to the distractor that they're supposed to ignore. So this is exciting to do this kind of work also to see whether we'll be able to replicate effects with just single word targets. And this was it for me. Thank you very much for having me and for being here. Excited to see what comes next from Johanna and questions you guys have.
Thank you so much, Yanina. This was fascinating. We do have loads of questions. I will give you a bit of time to read them while I do just the wrapping up. You can have a look at them, but I'll read them out in the end and we go through all of the questions. So for anyone who hasn't had an answer yet, I know from the Gorilla team there have been a few answers already. But anything for Yanina, we'll go through them. For now, let me just share my screen again. And we will have a look. I know I'm going to probably answer a few of those questions as well. Let me just share my screen and go back to where we were here. And there we go. Okay, perfect. We've done this already. Let me just move on to the slides. So we had a few questions about how does eye tracking actually work in the browser. So I just wanted to give you a little bit more background information of what eye tracking does. What we've seen today with Yanina's research is the eye tracking zone 2, which allows you to add basic eye tracking functionality to your task by utilizing a participant's webcam. Under the bonnet, what that does is that it uses version 2 of WebGazer.js, which is a library, and this is an eye tracking library that uses common webcams to infer the eye gaze locations of participants in an experiment in real time. So it works by using a participant's webcam to detect a participant's face, and it then uses prediction models to infer gaze locations on the screen in real time. The current zone does not provide data which you can reliably detect fixations, saccades, scan paths, and blinks with. Instead, it provides you estimates of gaze locations with an associated confidence. So these can be used to create heat maps of images or percentages, as Yanina was talking about, for the occupancy of areas of interest. We usually say that it works in quadrants, exactly what Yanina explained, where you've got the top left of your screen, the top right of your screen, and the bottom left and the bottom right. And you're able to predict, or the WebGazer data will show you where your participants looked at in those 4 quadrants. This is about the level of detail that eye tracking at the moment with WebGazer allows you to do. Just a quick note on ethics. I know a lot of researchers are ask themselves questions about it. The webcam images used in the eye tracking zone are translated automatically into coordinates on the participant's computer. So all Gorilla receives is the coordinates data, and the webcam images that would usually be recorded from participants are only used to determine the coordinate data and are not saved. So your participants will not be on the screen, and you won't get a recording from your participants of their faces. Now, how does it work in Gorilla? We have 3 different modes which we're using, and Yanina has shown us a few of those already and mentioned a few. First of all, we've got the calibrate mode, the record mode, and then the upload mode. Now, in the calibrate mode, we've got an initial calibration, which is followed by a validation. And in the validation stage, the eye tracking zone tests the predictions it is making and figures out whether those were correct or incorrect, whether it needs to adjust to them. If it finds that its predictions for a number, which is set by you of calibration points, are closer to a different calibration point than to the intended point, the calibration will be considered failed and it will be retried. So this gives your participants the opportunity to really make sure their calibration is working. Now that the second mode, the recording mode, we do exactly what it says on the tin. Participants' eye gaze locations on the screen are tracked in real time. And both the calibrate mode and the record mode should be used at least once within your task to make sure that the calibrating is working, and then you can go on to recording your participants' eye gazes. The upload mode is optional, and it should be used on a separate screen at the end of the task or the block if you want to combine eye tracking data from multiple trials into one file. So for the best results, we recommend usually repeating the calibrate mode approximately every 10 trials or 3 minutes. This will help you to account for participants' head drifting or body repositioning, which could affect this gaze detection performance. Now, if you want to learn more, my colleague Holly is going to post a tutorial which walks you through all those different calibration modes which we have in Gorilla available, which you can have a look at, and that explains quite well how those modes work together. And then finally, I've got a very important update to make. A few of you might already have heard about this at the moment, and what Yanina has shown us, eye tracking is only available in our legacy tooling, which means that it is Task Builder 1, and I know a lot of you might be using Task Builder 2 at the moment for their behavioral tasks. However, our development team has been very busy updating things and will be ready to launch our eye tracking in Task Builder 2 in just a couple of weeks. So please just bear with us, we'll get there, and we are very excited for eye tracking to be very soon available in Task Builder 2 as well. We also have a very good panel discussion from a few years ago about eye and mouse tracking in general, which if you're interested in it, again, Holly is going to post that in the chat. You can find it at that link she's going to post. Now, if you are interested in Gorilla in general or the eye tracking feature, which we've shown you today, feel free to sign up. It's completely free to try it out. And for the eye tracking, what we ask you to do is just get in touch with us and we'll be able to add the eye tracking to your account. Again, that doesn't cost you anything. In the support contact form, which is going to be sent around in the chat as well, you can choose better feature access at the bottom of it and then eye tracking 2, and that will allow you to get access to the eye tracking feature so you can try it out in Gorilla as well. And then if you have a question about it, if you want to chat with someone from our team or ask a question for Yanina now, while she's still on the webinar with us, then feel free to just get in touch and feel free to post your question in the chat. This is it from me. Thank you all so much for coming today, and we're giving a big applause to Yanina. I'm going to do that myself, just like that. Unfortunately, we're not in the room all together, but yeah, thank you so much, Yanina, for being here.
Thank you for having me. Bye-bye.
Thank you. Bye.